All right, listen up, because today we're pulling off the perfect heist. Welcome to this masterclass explainer designed specifically for the focused learner who wants to absolutely master their Cambridge exam strategy. Think of this as your Ocean's 11 briefing. To crack the vault of top grades, you can't just brute force it. You need to assemble your team of cognitive specialists to pull off the perfect, airtight answer. Today, we are undertaking an insider strategic debrief on what is widely considered a classic, high-stakes trap across multiple syllabus codes. Whether you're sitting for 0580, 0606, additional mathematics, 4024, 4037, or 4040, we are looking under the hood of a very specific, notoriously tricky mathematical challenge, differentiating the expression open parentheses 3x squared plus 4, close parentheses, to the power of 1/3. We are going straight to the examiner's playbook to see exactly how you should approach this. Because here is the secret. It is not just about getting the right final answer. It is about proving your methodology so flawlessly that you guarantee you capture every single available mark. So grab your blueprints and let's get into it. Here is the syllabus and roadmap for our heist today. First up, the chain rule challenge. Second, the method mark strategy. Third, the top 3 examiner warnings straight from Cambridge. And finally, our bulletproof execution plan. Deconstruct, solve, evaluate.
So here is the core challenge. How do you actually differentiate 3x squared plus 4 all to the power of 1/3 without needlessly bleeding easy marks? This specific equation is an absolute battleground. It looks deceptively simple, but candidates consistently drop points here. Let me introduce you to 2 classic profiles we see all the time in these past papers. First, we have Alex. Now, Alex overloads his paper with raw mathematics facts. He writes down every formula he can think of, scribbling wildly in the margins, completely ignoring any logical analysis or structure. It's just a wall of algebra. Then we have Sam. Sam rushes. Sam is the speedster who sees the numbers, skips reading the specific command word requirements, completely bypasses the intermediate steps, and just slaps down a final answer. When you put their flawed answers side by side, they are covered in red pen marks from the examiner. They didn't lose marks because they couldn't do the math. They lost marks because they didn't understand the strategy. They didn't show the examiner the precise analytical steps required.
Which brings us perfectly to Section 1, the chain rule challenge.
When a Cambridge examiner gives you this fractional exponent equation, they aren't just checking your rote memory of a derivative formula. They are actively targeting 3 distinct cognitive domains, which form their assessment objectives. First, knowledge and understanding. Do you actually know what a rational power means and what the chain rule is? Second, application. Can you actively apply this rule to a nested function without making basic arithmetic errors? And third, analysis. Can you deconstruct the inner and outer functions logically? You have to prove mastery across all 3 of these domains simultaneously. Alex fails on analysis because his work is a disorganized mess. Sam fails on application because he skips the foundational steps. You need all 3 to crack the vault. The theoretical architecture of differentiating this specific function rests on precise definitions, causal relationships, and most importantly, integration with other syllabus areas. The principal examiner reports explicitly highlight that candidates who reference cross-topic connections achieve significantly higher marks. Think about it. The chain rule doesn't exist in a vacuum. It connects to kinematics. It connects to rates of change. It connects to finding stationary points. It is about seeing the wider, interconnected mathematical landscape, not just the isolated algebra problems sitting right in front of you on the page.
Let's move to Section 2, the method mark strategy. Now listen closely, because this is where we turn those red examiner marks into green check marks. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, back to the strategy. This is a total game changer. The method mark strategy is a grading principle where marks are awarded specifically for demonstrating the correct procedural framework, step by step. In the humanities, you might use the Peel framework, point, evidence, explanation, link. Well, top students apply a mathematical version of Peel to their answers. Your point is defining your variables clearly. Your evidence is the explicit differentiation of those specific parts. Your explanation is showing the algebraic manipulation, and your link is tying it all together with the formal chain rule formula. For our specific equation, that means explicitly showing what you define as your u-value, the inner function, before you even attempt to differentiate, proving a rigorous logical process to the grader. You have to interpret relationships and draw evidence-based conclusions that are undeniably visible on the page.
To effectively capture those method marks, you absolutely must adhere to strict presentation conventions. Like I said about Alex earlier, It is not enough to scribble your chaotic working in the margins. You are developing professional analytical skills here. Examiners expect proper headings, correct terminology, appropriate formats, and incredibly clear annotation. Think of this as the blueprint for your heist. If you write let u equal 3x squared plus 4, you are applying correct terminology and formatting. You are actively making it impossible for the examiner to deny you those critical method marks.
Moving on to Section 3, the top 3 examiner warnings.
We've dug through the data, and there are exactly 3 major catastrophic pitfalls that consistently cost students their top grades on this specific topic. If you can anticipate, recognize, and avoid these 3 traps, you are automatically catapulting yourself into the top tier of candidates. The first classic mistake is providing vague answers. Examiners explicitly state that answers on differentiating expressions like this are frequently far too vague. This is exactly what Alex does. He might know in his head that he needs to multiply by the derivative of the inside bracket, but because he doesn't explicitly write down du by dx equals 6x, that step practically doesn't exist to the examiner. They demand explicit, specific details. Never ever assume the examiner knows what you mean. You must write it down explicitly and methodically. The second massive warning contrasts poor formatting with the strict conventions we just discussed. This is the trap Sam falls into. Students consistently forget to check their format and command words. If the question command word says show that and you just jump to the final line, you get 0 method marks. If your answer is disorganized, lacks appropriate mathematical notation, or is missing clear annotation, your response will be heavily penalized. And here's the kicker. That penalty applies even if your final mathematical conclusion is technically correct. The procedural framework matters just as much as the raw math. The third massive trap is providing generic, disconnected answers. You must always link every single point back to the given context. If this derivative is modeling a specific physical situation, like the velocity of a particle in a kinematics question, your differentiation steps and your final evaluation must reflect that exact context. Context-specific answers prove true, deep comprehension to the examiner. Stop scrolling. Subscribe to our YouTube channel, AC Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into Section 4, Deconstruct, Solve, Evaluate. This is where we run the interactive workshop. This is your master system. Imagine a 60-second timer on the board right now for a data scan. Look at the complex expression. Step 1 is deconstruct. We break this intimidating math into logical, highly manageable steps. We identify the inner function, our u, as 3x squared plus 4. We identify the outer function as y equals u to the power of 1/3. Boom, deconstructed. Step 2 is solve. Now we execute systematically. Differentiate the inner function. The derivative of 3x squared plus 4 is simply 6x. Now differentiate the outer function. Using the power rule, 1/3 comes to the front, and we subtract 1 from the power, giving us 1/3 u to the power of negative 2/3. Now we link them using the chain rule, multiplying them together. 1/3 multiplied by 6x gives us 2x. Substitute our u back in, and we are left with a beautiful, fully justified final answer. 2x multiplied by open bracket, 3x squared plus 4, close bracket, all to the power of negative 2/3. Step 3 is evaluate. We step back and interrogate our own work. Is it mathematically sound? Did we drop a negative sign? Did we address the command word?
Part of that crucial evaluative layer is finding the flaw before the examiner does. Let's do a speed writing challenge mentally. If you had 30 seconds to write a perfect justification paragraph for your steps, what would you say? You would use mathematical evaluation tools. You could think about the reverse process. If I integrate this, do I get back to where I started? You verify the logical progression of powers. We started with a positive 1/3 power. Taking the derivative means we subtract 1, so we should absolutely end up with a negative 2/3 power. That logical progression checks out perfectly. By supporting your algebraic steps with this clear, undeniable evidence, you prove to the examiner that your logic is completely airtight. You leave them no choice but to award full marks.
And this brings us to a foundational quote directly from the Cambridge syllabus emphasis. It states, top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. That, right there, is the ultimate goal of this entire explainer.
By mastering our mathematics success blueprint, the method mark strategy, the strict conventions, and the deconstruct solve evaluate framework, you aren't just learning how to differentiate one specific fractional exponent. You are building a connected, robust conceptual architecture. You are assembling a toolkit that you can transfer to absolutely any unfamiliar, terrifyingly complex mathematical problem they decide to throw at you in paper 2 or paper 4. You've essentially decoded the matrix of the exam.
So, we've laid out the entire cheat sheet recap for you. You have the 3 rules that guarantee top marks: command word decoding, applying our mathematical peel framework, and managing your time matrix effectively. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSU to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSU and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.